we left off, we saw that the dot product gives us information about the angle between two vectors, which means we can use this to understand the relative position of a vector A with respect to the x, y, and z axis. So here I've drawn a vector A which points to some point in 3D space with some x, y, and z values. And we are interested in finding the orientation of this vector A with respect to the three axes. What does that mean? It means I'm interested in finding this angle it makes with the x-axis, denoted by alpha. I'm interested in knowing this angle it makes with the y-axis, denoted by beta. And I'm also interested in knowing this angle it makes with the z-axis, which is called gamma. If I look at just the alpha, then from the dot product definition, I know that this will be the dot product with I cap divided by, so I'm taking the unit vector along the x direction. And A dot I is just going to give me A1, which is the x component of the vector A. And the magnitude of unit vector is 1, so I'm just left with magnitude of A. Similarly, cosine beta is going to be the second component, which is the j component, still divided by magnitude of vector A, and cosine gamma is going to be A3 divided by magnitude of vector A. Now notice that what is magnitude of vector A? Remember, this is square root of A1 squared plus A2 squared plus A3 squared. Or what is this squared is A1 squared plus A2 squared plus A3 squared. Or 1 is A1 squared over magnitude of A squared plus A2 squared over magnitude of A squared plus A3 squared over magnitude of A squared. But we just found that these are actually just the cosines of the angles. So we get this nice relation here. We can also write the vector A is simply its components A1, A2, A3. But A1, A2, A3 we have seen is actually magnitude of A cosine alpha, magnitude of A cosine beta, and magnitude of A cosine gamma. So this is magnitude of A cosine alpha, cosine beta, cosine gamma. Or the vector A divided by its magnitude gives us exactly the cosine values, which are called the direction cosines. So the direction cosines of, we don't need to write the word vector. The direction cosines of A are exactly the components of the unit vector in the direction of A. Example, find the direction cosines of the vector I plus 2j plus 3k. So first I'm going to find the magnitude, which will be 1 squared, 2 squared, 3 squared, root 14. So we have cosine alpha is going to be 1 over root 14 because that's A1. Cosine beta is A2 over magnitude, and cosine gamma is A3 over magnitude. And from here, I can find the angles. Alpha is just going to be inverse cosine of root 1 over root 14, which comes out to roughly 74 degrees. Beta is going to be inverse cosine of 2 over square root of 14, which comes out to 58 degrees. And gamma is going to be cosine inverse of 3 over root 14, which comes out to roughly 37 degrees. So that's how we can use dot products to find direction cosines. Now there's one more application of dot product that we will cover in the next video, which is called finding projections.